Across the nation, as people wake up and begin their mornings, they traditionally have one thing on their breakfast plates.
A phenomenon designed to ruin your day right from the very start. The buttered toast phenomenon.
I'm Sophie and this is my toast-loving friend Matthew.
That's right, I have a love-hate relationship with my morning toast.
We all know Murphy's Law. Anything that can go wrong, will go wrong.
Although not scientifically proven to be true.
In the case of your buttered toast landing face down, everyone seems to think it is.
But what else could it be?
Although hard to believe, there have been physicists to study this seriously. Matthew's 1995 began it all by modelling toast as a rigid, flat object.
So essentially, incredibly burnt toast. But there was clearly more to explore, because 6 years later, Bacon et al. 2001 introduced friction in a closer look at buttered toast. We won't dive into friction today, but we'll use Bacon's experimental results.
Toast rotates when leaving the countertop.
And the physician's favourite question is, why? As you're rushing out the door because your alarm didn't go off,
leaping to grab your unevenly buttered slice of toast,
you miss and your breakfast slides off the table,
plummeting towards the floor. Must be the butter weight.
But it's not, as that's essentially negligible, according to Matthew's research paper in 1995.
So it's the table's edge?
Exactly. Once the toast passes its centre of mass, gravity continues its rotational torque.
And that torque is the real culprit.
As the toast falls, it spins.
The rate of that spinning is its angular velocity, constant once the toast enters freefall.
Assuming air resistance is negligible.
Yes, angular velocity is the rate at which an object spins around an axis. Here, that's the toast centre of mass. One full rotation is 2 pi radians. To calculate the rotation before impact, we need angular velocity and time in the air.
For the time spent in freefall, we use a typical table height of around 0.75 metres, confirmed by Matthew's research paper, and SUVAT.
This gives us roughly 0.39 seconds.
No wonder we can never catch it, but that's only half the problem.
Stay with us.
To find angular velocity, Bacon et al. 2001 measured real toast rotating off tables with different overhangs.
Greater overhang causes greater angular velocity.
Bacon typically referenced a 1.1 centimetre overhang, giving us an angular velocity of around 11.5 second radians per second.
Using that value in a 3 full time of 0.39 seconds.
258 degrees.
Angles between 90 and 270 degrees means that toast lands butter side down. So angles below 90 and above 270 means the toast lands butter side up.
258 degrees sits within the butter side down zone.
Meaning your breakfast is mathematically doomed.
By calculating the upper and lower bounds.
A butter side down result occurs if its angular velocity is between 4.03 and 12.08 radians per second.
Comparing this to Bacon's table, this corresponds to overhang of nearly 0 to 1.3 centimetres.
Assuming 2.1 centimetres was an anomaly. But what if the table wire?
More height, more freefall time.
More freefall time, more rotation.
Keeping the same overhang and angular velocity, we can calculate the minimum table height needed for the toast to rotate beyond 270 degrees, planting butter side up. My toast is done.
A height of 0.813 metres.
Only 6.6 centimetres over the height of our average table.
For fun, dropping your toast from the Burj Khalifa, assuming air resistance was negligible,
would cause it to complete 23 full rotations.
And land butter side up on its 24. So all it takes is the tallest skyscraper in the world.
Or just a 6.6 high table. This is why physics ignites that spark within us. Everyday experiences can be simply explained by visualising the world in a different manner.
The simplest of accidents turning into an entire phenomenon rather than just a stroke of bad luck or Murphy's Law.
The blend of thousands of theories and laws working together to create our world around us.
The constant knowing that there is more physics within the world than we will ever be able to grasp keeps us searching for the smallest of mysteries in our daily lives.
And all we need to do is ask why.
Physics is so expensive. The thing you'll be telling me is that there's quantum physics inside my cup of coffee. But that's not possible, right?
You landed the right way up.